Going back and forth between hexadecimal and binary or decimal is actually pretty simple. The reason it's pretty simple is because of the similarity between decimal and hexadecimal. Up through 9, they're exactly identical. 10 is A, 11B, 12C, 13D, 14E, and 15F. If you can't remember those numbers, you can count them on your fingers. It's really not very difficult. So I've got 9, and if you've said, for example, C, I just go, let's see, 10, 11, 12, ABC, right? And then C equals 12. So it's really easy to count them on your fingers. Now, when you're dealing with only 16 different characters, 0 through 15, it's really not very difficult to go back to binary from that. So sometimes I use these as intermediates. If I would need to go from hexadecimal to binary, I would use decimal as sort of an intermediate, translate into one, and then translate that into the other. So, for example, if I'm looking at a, let's look at D here. Well, D is 13. Again, I can count that if I can't remember. A, B, C, D, that's 4. So 10, 11, 12, 13. So 13 is the fourth one. Well, 13 is not very difficult in binary. This is the 1's place, 2's place, 4's place, 8's place. So 8 plus 4 is 12, plus 1 is 13, and I've got it. So you only have four of these things. You got 1's place, 2's place, 4's place, and 8's place. And certainly you could add 8, 4, 2, and 1 pretty easily. So it's not really very difficult to put these together. Now, when it goes to actually creating numbers, let's just look at some examples. We're really just going to string together the binary. Now, as these numbers get larger, it turns out that you can translate them one hexadecimal digit at a time. So that makes it real easy. Let's look here. This is a 6C. Well, 6C is real easy. I've got a 6 here. There's the 4's place and the 2's place. 4 plus 2 is 6. And then a C. Well, C, here's the 8, 9, 10, 11, 12. So that's the 8's place and the 4's place. 12, and 12 turns out to be equivalent to C. So it's real easy to put them together. Here's a 2001. Well, I just start by doing a 2. That's a 1, 0. And then a 0 and a 0. And then a 1, which is a 0, 1 here. And I'm done. I just put them back together, string them together, concatenate them, and I've got it. So it's really, really easy to do this. So let's just do a little bit harder one. Let's just do something at random. 32AB. All right, well, let's just make a 3 in binary. That's the 2's place and the 1's place. So 2 plus 1 is 3. Now we'll make a 2. There's the 2's place, so that's a 2. Now an A, remember we went up through 9, so then A becomes 10. So let's make a binary 10. That's the 8's place plus the 2's place. 8 plus 1 plus 2 is 10, so we've got that. And then a B, well, if A is 10, B is 11, so we'll make a binary 11. 8 plus 2 is 10, plus 1 is 11. So we have it, 32AB. And if we want, we can just take these spaces out to concatenate them. And this is 32AB in binary. Now, we could translate this into decimal if we wanted to, but it would be a little trickier because we have to go up into what? 1s, 2s, 4, 8, 16, 32, 64, 128, 256, 5, 12, 10, 24, 20, 48, 4096, 8192. So that much of it is worth 8192, and we have to keep adding like that until we got to the end. But at least it can be done, and it's a lot easier to go from binary to decimal than it is to go straight from hexadecimal to decimal.